In this video, I'm going to show you how to analyze a repeated treatment design where we have S subjects, P periods, and T treatments. So it's important that you identify those parameters in your data set because you have to enter them yourself. So in order for the code that I'm about to show you to work, your data have to be structured in this way. So I usually have the first column equal to my subjects, which is in that carburetor data set are the 4 different carburetors. And so I have ones for P periods, and my number of periods in this case are 4, and then 2, 3, and 4, and then I arrange it as in terms of the period. So this is period 1 for subject 1, period 2, subject 1, so on and so forth, and then it starts all over again when we get to the next subject. And then the third column is your treatments, and there isn't any specific structure here. It depends on the design that you're actually using. For in order for the code that I'm about to show you to work, you have to have your data structured in this way, or else it's going to fail. It's very important that you have your your subject and your period effects to be arranged in this way in your data set. So if I highlight and run this code, sorry for the previous log, let's look at what this original data set looks like. So open this up. And here's what my data looks like. So again, you want the subjects to be arranged this way and the periods within each subject to be arranged this way. So in order for us to include carryover effects in our model, we have to do that special reparameterization that I showed you. So I was able to write some general code that'll work for any setup that you might have. All you have to do is tell SAS, actually, you don't even need to tell it what number of periods you have because it'll be able to figure that out on its own. You just need to tell SAS how many treatments you have because it'll be able to pick up how many periods there are if you arrange your data in this way. So I also need to calculate on the side how many treatments minus 1 so that it knows how many parameters to add. So all you need to do is enter what T is and then run these two let things and it'll calculate those variables for you. And then in this next data set, so we're creating a new data set called carb carry, and I'm setting the previous data set that I just created. And this code right here is going to create those extra T minus 1 carryover effects that'll enter into our model. So all you need to do if you have a general data set is to tell SAS what you want the new data set to be called and what your previous data set is called. So I'll upload more general code in SAS that'll enter that'll prompt you to tell SAS what these two things are. So I'm not going to go into how this code is working. Maybe do it real briefly. So first it checks to see if you're in the second or greater period because we don't calculate carryover effects for that. And so then if our previous treatment is less than the last one, then it sets that element equal to 1. Otherwise, that means that the previous treatment was the last one, and then we sent all of our carryover effects equal to -1. And so all you need to do is highlight this and click Run. So I shouldn't have any errors here. And so here are my 4 minus 1 carryover effect design variables. So whenever I have a 4 in the previous treatment, the next one better have all -1s. So here 4 was in this one, and then they're all -1s in the next period. Also, whenever I have period 1, they should always equal all zeros, which we see here, 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 and then here. So it seems to be working the way I want it to. Now remember, when we do our analysis, we want to treat C1 to C3 as quantitative variables because we're doing our own sort of dummy variable coding. But all the other ones are going to be considered to be classification variables. So here I'm going to do an analysis, a carryover analysis on that carburetor data. So if I didn't want to include carryover effects, then I would just delete C1 to C3. Maybe I'll just comment this part out right here. And let me get rid of this part right there. So this would be just analyzing this like a Latin square design. So if I highlight it, click Run, here's my output. So my residual effects are, residual MSE estimate is 10.667. Treatment effects look to be significant. I'm not really sure if these two block effects are significant or not. I have to do some sort of relative efficiency calculation to get a better handle on that. But if I wanted to include carryover effects, the way I do that is to do C1, C2, C3, and you'd have to do that for all the ones that you create. A shorthand way of doing this is maybe doing C1 to CT1. That might be a shorthand way of doing that if you understand kind of SAS shortcuts. But for the time being, might be easier just to type them all out ourselves just so we know what's going on. So again, I don't put C1, C2, and C3 up in the classification statement. I include them just in my model statement because I want them to be quantitative. Now, if I want to do an overall test for my carryover effects, I want to do contrast and then C1, 1, C2, 1, and C3, 1. So these ones are just saying include this this effect in my model. So all these, the way we parameterized it, are estimable. So this is going to test whether they should be in the model or not. So the reduced model in this case has all of these three dropped, which is dropping that carryover effect entirely. Highlight that code, click run, and we see what we had before. The overall carryover effect is insignificant, but we'll include it just for demonstration. We do see our MSE reduces a little bit. Before it was 10.667, so we should see this reduce because we're adding some elements or some extra things to our model in this case. Okay, so other variants of this, one thing I mentioned is you might want to make your subjects random. And so our subjects in this case is carburetor. And so I mentioned that you want to make sure that if you're making carburetor random, that you don't put it in the model and the random statement. So I'll just do that to show you what happens. So if I do carburetor in both of them and highlight this and select run, it gets angry at me. It doesn't put out any F values or really anything. And in the log it says variance component's not estimated due to a singularity in the expected mean squared coefficient matrix. And that's because of the fact that our random effects and our model matrix have the same. I think this actually will run if you use the REML method, so not type 3. It does, and that's kind of confusing. Now it does give you some hints that something weird is going on. It says the final Hessian is not positive definite, and it gives you kind of a humongous estimate for carburetor. This is 3.8 times 10 to the 33rd power, which is a little ridiculous. So just for best practices, it's best if you're going to make carburetor random, you don't include it as a fixed effect at the same time. So let me run it like this. Let me go back to doing my type 3 sums of squares because that actually tells me how my tests are constructed. Okay, and then we can see that this behaves a little bit nicer. We do see my estimate change a little bit for carryover, and that's just because of how it constructs the tests in this case, and we don't have a design that's totally balanced. Before we would have this be equal if our design was balanced, but that's not the case right now. Okay, so what are some other variants of this? So let's keep carburetor as random, and let's say we add an additional complete symmetry component. Now I'm guessing this is going to be a problem, so I do repeated, and then subject equals carb, type equals AR1. Well, let's do complete symmetry actually, and do R-core just to see what that correlation matrix looks like. So this should actually give me an error because I'm defining the same sort of correlation structure here and right here. So let's run this code. First, it gets mad at me because type 3 estimation is not available with this model. So whenever you use a repeated statement, you can't use type 3 sums of squares. So I'm going to change this to REML or just delete it entirely. So let me highlight this and select run. It's not really giving me too much of an error other than the fact that it says carburetor has 7.3067 and then the complete symmetry parameter is 0. So it's not quite telling me that there's a redundancy in the way I've done my model other than saying that the final Hessian is not positive definite. So again, doing complete symmetry is the same as saying carburetor is a random effect because it's giving the same random effect to all observations having the same carburetor. That's not going to be true if I give this an AR1 structure. So let's highlight that and select run. Now this also actually is giving me an error, so there is going to be some redundancy. It looks like right now it's kind of competing between doing a complete symmetry model and an AR1 model. So if you're going to do an AR1 model, it would be best to probably just drop the carburetor out of it being a random effect and maybe just include it as being a fixed effect. And so the AR1 model should be inducing some extra correlation while the carburetor will be doing some overall effect. You could also probably just drop carburetor entirely and have this sort of correct for the fact that observations from the same carburetor are correlated. Okay, this is again giving me some sort of error, saying that an infinite likelihood is assumed. So even some of the suggestions I'm giving you, again, maybe not the best. Let's just drop carburetor entirely and just have the repeated part of this. And there we see we have some consistency with what's going on. So here is the estimate of our rho parameter. It's going to be the correlation between two consecutive periods. And this is going to be 0.6844 squared. This is 0.6844 cubed. So you can see how that kind of decays. So hopefully you can see how sometimes doing repeated structure on top of another model can kind of give some inconsistency in how the model is estimated. And really it's because doing a carburetor overall effect and then an AR1 structure was kind of overwhelming SAS. And then it's valid to just drop carburetor and include it as a repeated statement because it's still taking into account the correlation between observations from the same carburetor. Both models are doing that. They're just doing it in different ways. And again, if you wanted to compare models, you could go to the AICC or the BIC. That would require some more research on your own to figure out which one might be more appropriate for you. So hopefully you saw a lot of the different options that you could look at, and then also understand how you can generate those C1 to C3 columns.